What do guys do when they don't reply to messages? They watch the LEGO Train Interception Challenge. If you want to stop a moving train, ordinary guardrails are simply not enough. First, I install simple lifting railings for interception. This device only blocks regular vehicles, but makes the train lift its front in a funny way. Then I upgrade the structure of the lifting railing, adding fixed supports to the end of the lifting rod. Now we test the actual effect of the new barrier. Yet the speeding train carries huge impact force. It breaks through easily and ruins my plan. Facing failure, I choose to keep upgrading, focusing on reinforcing the base of the whole device. The improvement shows obvious results. The fast train is blocked and cut off horizontally. The train splits into two separate parts. After upgrading the interception device, it's time to strengthen and modify the train. The vintage steam train is upgraded into a classic greenskin train. Next, we test the collision power of the new train. The train moves slowly to test the obstacle at first, then reverses to build up impact momentum. It slams forward violently and smashes the lifting rod. I have to replace it with thicker reinforced railings, but the train strikes even more fiercely this time, dragging the whole barrier device away completely. Since regular upgrades no longer work, I have to use special modification ideas. I add buffer and shock absorption parts to the railing. Then I test the practical effect of the new design. The result shows its effect is very limited. It only slows the train down for less than 1 second, but the overall design concept is still correct. I optimize and upgrade the original buffer device, adjusting the structure to increase friction resistance. The high-speed train charges forward head-on. This time my design works perfectly. The train is forced to stop after the fierce collision. The defense device wins a phased victory. Then the train gets a full round of upgrades. The number of wheels is doubled. Linked connecting rods realize synchronous operation. This high-speed bullet train has extremely strong power. The fast spinning wheels even lead motion blurs. How powerful will the newly modified train be? Let's wait and see together. The bullet train has a long acceleration distance. The upgraded power system delivers explosive strength. It deals devastating damage in the instant of impact. The lifting barrier shatters and breaks apart in the air. I still refuse to give up after repeated failures. I developed the third-generation buffer device. For elastic springs are added in this upgrade, adopting a two-stage segmented shock absorption structure. Meanwhile, I replace larger tires with stronger friction. All preparations are done for the new defense test. The bullet train runs at an extremely fast speed. The first round of defense ends in failure. It slows the train down for a short moment, but the whole interception device is overturned. I switch to extra thick, larger tires once again. The fierce confrontation ends in a lose-lose situation. All current defenses cannot hold back the train. The bullet train gets further performance upgrades. Extra batteries and drive motors are installed, providing sufficient power for the rear wheels. This upgrade brings immediate improvement. The once solid barriers become fragile in an instant. After all mechanical interception methods fail, I realize the core logic of simplicity and practicality. I build a solid 4-layer brick wall for defense. Practice finally proves the most plain and simple solution is always the most reliable.